So my name's James Sutton. I'm a software engineer working for IBM Research, and as mentioned, I cover all kinds of areas from IoT to machine learning and AI, and pretty much everything in between. Our team based in Hursley, just near Southampton here, pretty much are the sort of one-stop shop for if you've got a problem and there isn't an off-the-shelf solution for it yet, then you come along to us and we'll connect you with the research that's out there and sort of try and make that first prototype or proof of concept. And that's really where we came across the Mayflower autonomous ship, which was actually being driven by some of our other colleagues in IBM. But I'll start off with what is the Mayflower Autonomous Ship project. As I'm sure some of you may know, just over 400 years ago, the original Mayflower sailed from Europe to the New World. It left from Plymouth in the UK to Plymouth in Massachusetts. And there was around 2020 was the 400th anniversary, and they wanted to find a way to commemorate it in some fashion. There was an idea maybe to build a replica of the original ship. But fortunately for this project, a guy called Brett Phaneuf, who works for a company called M-Subs, or CEO of M-Subs, which is based in Plymouth and builds autonomous vessels, said, actually, he happened to be in the conversation, thought, why don't we build something that looks to the next 400 years of the marine industry? So rather than looking back and sort of looking at all of that, let's see what are the new challenges we're going to be facing, what are the new technologies we're going to be needing, and so forth. And so that's really where the Mayflower autonomous ship sort of concept came about, followed by several years of very hurried getting everybody together, figuring out how do we build this and trying to get it ready in time for 2020. Something happened that year. I can't quite remember what, but there was a little bit of a delay. So the sort of main goals that we had for this ship was to build a fully autonomous, crewless, and sort of full-size ship capable of traversing oceans. And now, in order to do that, you've got to have something to direct it and control it. So we needed an AI captain that could take all of the data that the ship had on its own and use that to influence its decisions and plan and basically plot its course from one position to wherever we wanted in the world. And then we wanted to sort of use this as not just a proof of concept, but to develop a platform that could be used going forward for future technologies. And then finally, we wanted some kind of payload for it. Crossing the Atlantic is a great challenge for us, but really we wanted to be doing stuff whilst we were on the way. So we looked at could we use this as a platform for science, for gathering data about our oceans, and hopefully sort of furthering the sort of ocean science and climate change fields. So there she is. This was in earlier last year when she was doing some sea trials down near Plymouth. She's a trimaran, about 15 meters long, 6 meters wide. She's got solar panels on the top, but then also a biodiesel generator, so that we can get through some rough weather and things like that when we need to, but when it's nice and sunny and clear out, we're sort of taking as much benefit from that as we can. For navigation, we've got radar, AIS, but then also a sort of suite of cameras around our mast giving us a 360-degree view of the world around us. And that's been trained on millions of images that were captured in the years leading up to when she set sail from around Plymouth of basically sort of every single marine object we could find. And then what you don't see underneath is the sort of suite of sensors that we're using to take all kinds of readings about the water that we're in, what can we see, taste in some cases, and even hear. So the plan was crossing the Atlantic. Originally, the route was a little bit more straightforward, but as with all of these things, it never quite goes to plan. So our first attempt, which was in 2021, we managed to make it all the way to the Isles of Scilly before, unfortunately, we had to turn around and come back for some maintenance. We'd done huge amounts of sea trials around and about Plymouth, but it's always the case that when you actually sort of really push the boundaries into places that you've never tested before, stuff happens, stuff breaks. And then we fixed it up, made some improvements, had a bit more time to develop some of our experiments, and then we gave it another go. So April to June 2022, she made this journey. So you can see in this case, we made a little pit stop at the Azores. That was another sort of hardware fault we found. One of the things that we really noticed with this is if you've got a fully manned ship, you've probably got a store somewhere where you've got spares for your generators and your engines and things like that. It's a very small ship, so we don't carry spares on her, and even if we did, we've not got anyone on there to fit them if we needed whilst we were on our way. So this was just one of the things that we really picked up on in the journey of that, we tried to make sure that all of the hardware was as resilient and robust as possible, but sometimes stuff still goes wrong, and so you need to have plans around to resolve that. So in this case, some of our colleagues got to spend a few days in the Azores, which was very nice for them. After that, we carried on. We had to make a slight diversion up towards Halifax and Nova Scotia because there was a rather large storm system coming in. And the Mayflower is not particularly fast on her own. And so rather than really trying to push our way through that storm system, we decided we'll go north and then we'll sort of hug along the coast on all the way down. And then we finally made it to Plymouth, but I'll get to that in a little bit. So the AI captain, we've got a nice flashy sort of video here showing sort of what's going on in the mind of it. AI systems currently are really, really capable, very complex, but one of the problems they have is that you really need to make sure that in safety critical systems, like a ship at sea, you need to make sure it's making the right decision every time and you can explain why it's making that decision. So what we've got here, the Mayflower is sort of using its suite of sensors. It can see everything around it. It's picked out on its AIS and its radar that there's some obstacles around, and then it's using its visual recognition to sort of confirm those assumptions. And maybe there's things out there that don't have AIS, like flotsam and jetsam kind of things floating around us. We then pass all of that information through a fairly robust rules-based system. So we've, rather than just putting everything into sort of a black box, as you'd call it, and hope you get the right answer out the other end, we've given it some very specific rules about how to react to the world around it. It figures out maybe what the best route for it is, and then it will sort of readjust its course and head on its way. So where are these rules coming from? So the main sort of nav control model that we've got has been built up with a set of rules from the Colregs. Where this came from was quite interesting in that we use a piece of IBM software called ODM, Operational Decision Manager, which I won't bore you too much with the technobabble, but it's pretty much used if you want to have a mortgage approved or see if your insurance policies, insurance claim is going through, because it's sort of a rules-based system. You put the inputs in, you've got all these rules, and you get the answers out. And we found actually the Colregs were quite good for sort of fitting into this system and reusing it in this way. So actually we found a really nice existing piece of software to do this. And as I say, because it's a rules-based system, you can see exactly why it made the decisions it made, which is really important. Finally, we had a sort of a second layer on top, which was using the SOLAS sort of regulations and guides, and this was really looking at sort of scenarios where, okay, we've followed all of the rules, but what if everyone else isn't following the rules, or they've made a mistake, or it's something that can't follow the rules because it's unpowered? We wanted to make sure that we had all cases covered for that, and sort of the overriding sort of policy that no matter what, we don't hit anything. That's always the main goal. So decision-making process, we've got sort of this our pyramid of needs. Humans have them, the ships have them too. So the very core ones we have are things like making sure we understand the local situation. Is the ship working? Are all of our components operational? What's around us? Face into the waves, avoid collisions, fairly straightforward stuff. Then we get a bit further up, which is going, okay, let's look further out. Let's see what's on the sort of the horizon to us. Let's see what's heading our way. We're going to have to deal with in 10, 15 minutes. And make sure we respect the rules at sea as best as we can. And then finally, right at the top is our mission. So we're trying to make it from Plymouth in the UK to Plymouth in the US, and we're trying to conduct some science along the way. And the ship can dynamically decide, how it manages all of its resources in this process. So the science experiments used power. We used resources on the ship, and there were cases when we were going through sort of heavy storms and when dark skies, when the ship didn't have enough power to power the science experiments and the prop. So it would basically say to us, let's shut the science experiments down for an hour or so. We'd cleanly shut down and wait to be woken up again once the ship had enough power to do everything it needed to. So very much, we prioritized the health of the ship and not doing anything wrong as the main priority, and everything else can be scaled up and down as we needed. So it's a pretty small ship, as I mentioned, the spot here in the middle, which is sort of empty, that's basically the space that we had for our science payloads. So if I was standing up in it, it sort of comes up to about my neck. I have still got the bruises from hitting the inside of it quite a few times. You've got the sort of AI systems in the front of the ship, the sensors around the mast is slightly older design that I've got here. And then there's a whole load of other stuff that you normally would see poking out of the bottom, so most of our sensors and things. The challenge that we had, though, when we took all of the science teams that wanted to work with us, so we had teams inside IBM and in universities around the UK, was they were used to running science experiments. If they were, say, going out at sea, they would actually go out on the ship. They'd go out, they'd hang something off the end, they'd take a water sample, or they'd hang a hydrophone off the back. There'd be a person with that science experiment the whole process. Or, in other cases, they literally never left the lab. They'd have a lab and a huge amount of kit sitting on the table in front of them. So one of the things that we need to be able to do is to, shrink all of this kit down so that it could fit inside that space. It was about 2-3 meters big. And then also make sure that it could run completely autonomously for the duration of the voyage, which was a very new challenge for a lot of these science teams. So that's pretty much where IBM comes in. Our team was involved in designing a whole sort of science payload that could manage all of these different experiments plugged into it, capture that data, process the data if we needed to on the edge, and then send the results back to our systems using the SATCOM on the ship. There we go. All right, cool. So I'll give you a quick overview of some of these experiments and how we sort of shrunk them down. So we've got a whale population experiment. And this is around basically trying to identify the populations or where whales are as we were crossing the ocean. The data sets are quite limited still, mainly based on, if we've got sort of wave gliders or buoys out there recording, or manned missions taking hydrophones out to record. We wanted to see, could we do this completely autonomously? So we effectively worked on training a very large machine learning model on all the different vocalizations that various cetaceans might make that we could hear. So it's covered everything from whales through to, I think we've got lots of shrimp and things like that in some places, and dolphins and all that kind of stuff. But then specifying it to, right, we just want to track whales, and then when we hear whales, we want to clip that little bit of audio, figure out where we were when we recorded it, and then send that data back to land. So the team at Plymouth University, the idea would be that they would only get just a little clip of the vocalization and where it was and what was happening at the time, rather than a huge, massive, 300-hour-long data set. The work's been continuing. Every time we go out on a mission, you find more interesting challenges around environmental noise from the ship and things like that. But it's been carrying on, continuing quite well. And we hope that this will be useful for other people too. We want to share the information and the resources to do this with other teams around the world. Our second experiment is our ocean chemistry experiment. So this is using something called hypertaste that came out of the IBM research labs in Zurich. It's actually a digital tongue that was originally designed to be used to record if something like a liquid of some kind was a genuine or a fake. So you'd be looking at like a whiskey or a perfume. You'd want to know, was it the real deal or had it just been rebadged? They were able to effectively take this technology, turn it a bit on its head, and we had this whole sort of pumping apparatus that we installed inside the ship. And we were consuming water from the ocean as we were traveling across the Atlantic. We'd be classifying it, be looking for the concentration of carbonates within the water. So sort of trying to find the fingerprinting or tracking the effects of ocean acidification as a result of global heating. And again, that's been really successful. Again, the team learned a huge amount about it. This is an example where sort of they'd always be in a lab. They'd be working on stuff on a lab workbench. So designing something that can sit in a ship for several months, just continuing to work non-stop, was a really good challenge for them, which they really enjoyed, and it worked really well all the way along. So that was sort of quite a good example for us. And then we've got our open ocean wave energy. So this was a data collection experiment for another university. Again, the work is still ongoing here, but effectively we were taking the video feed from our cameras around the ship, recording the waves coming towards us, and then we were also using an inertial measurement unit at the same time to record the actual sort of impact of those waves on the ship. So this is looking to develop a video AI model where you could point a camera at the sea, maybe from a cliff or from another vessel at sea, and you could actually predict how much energy is in the wave that's about to hit you. Now, if it's about to hit you, that's not particularly useful, but you could, say, do recordings around sort of a coastline over a period of weeks or months and work out how much the sort of cliffs may be eroded, or if you're installing, say, a wind turbine or other equipment at sea, how much of a battering it's going to take in a particular area with different environmental conditions. So again, that's quite exciting. We're looking forward to seeing the results of that once all of that data has been crunched through. And then we've got our open ocean tides and sea level experiments. So this is using effectively really, really accurate GNSS receivers to try and calculate exactly how high the Mayflower autonomous ship is on the sea. And this is looking really at capturing and measuring open ocean tides. So obviously it's really easy to measure the tide when you're on the coastline. There's a meter ruler or something in the water, you can see where it is. We've got pretty good at predicting that now. But figuring out how high the tide is in the middle of the ocean when you've got no sort of solid ground to compare against is a bit more of a challenge. So that's where that particular piece of work is going, and we're sort of spinning up a PhD student at the moment to start chewing through that data, which is quite exciting. Am I okay for time? Brilliant. So we've then got sort of all of the kit that powered this. So as I mentioned, we had to run this completely autonomously. We had to take instructions from the ship around what we were supposed to be doing at different times. Had to be low power, low bandwidth, and it had to fit in a fairly small area of the ship. So one of the interesting things that we quickly learned when we developed our science pod, which could control all of these experiments and capture the data and process it, was that we didn't want to be doing it all the time. We didn't want to be running our experiments the moment the ship turned on and stop when the ship turns off, because at least during the sea trials, it spent quite a lot of time floating in Plymouth Sound, doing not very much at all, and it was just using up data resources and wasn't particularly useful for anyone. So a lot of the work that went into this process around about last year was looking at contextual science. So understanding where we were, what we were doing, and then deciding whether we enable and disable certain experiments on the fly. So for instance, the experiment using the cameras, looking at the waves around us, they were just standard cameras. They didn't really work too well at night. You couldn't pick up the waves or anything. So we disabled all of those visual experiments when the sun was below the horizon, depending on where we were in the world. We used geofences in a lot of cases to avoid collecting and sucking up water into the hypertaste experiment when we didn't want to, because we didn't want to clog the system up when we were near land and potentially bringing up dirty water that might have too large particles in it. Or again, capturing data when it just wasn't required. So we didn't need to be running our hydrophone experiment when we were inland because there was unlikely to be any whales near Turnchapel Wharf, which is where the ship was. The other aspect around this was sort of bandwidth and things like that. So SATCOM links, very expensive, not hugely reliable if you're a small ship that's sort of wobbling around in the water quite a lot. So we always had to give priority over to the team that was monitoring the ship. So we were getting video feeds back, we were seeing what was happening with the ship at all times, and they needed that for the safety perspective. So we always sort of were second class, and rightly so in that case. So a lot of the other work was looking at how do we compress all of this data and only transmit when it's really important. Tell us the interesting stuff you found without us having to ask for it. Tell us if you've got a problem, tell us if you fix that problem on your own, and all that kind of stuff. And then once it gets to land, it can automatically offload all of that data into the cloud when it gets near land. It's on a 4 or 5G link, which is what we had when we got it to the US in June last year. So that's the Mayflower. That is it next to the replica of the original Mayflower in Plymouth in June last year, which was sort of a really nice thing for all of us to see, especially as we've been sitting there sort of white knuckles for several months watching this little ship sort of totter across the ocean. We had a whole website that you could go to. It's still up there, mas400.com, and you could watch the video feed live, which is quite dull at some points, but quite exciting at others. There are a few seagulls that pop by for people watching, and you could also track and consume all kinds of the data coming off it. So now all of that data is with all the various universities and research teams around the UK and the world. They're digging through it and processing it. The Mayflower spent winter at the Woods Hole Oceanographic Institute near Washington, DC, and now is being prepared for a new mission, which is quite exciting, actually. It's going to be investigating sort of the twilight zone, so the, sort of that gap in the ocean. And it's going to be monitoring various different cetaceans and things that it can find there. But what's really exciting is going to be part of a small fleet. So there's going to be several manned vessels that are going to be collecting data, but then the Mayflower is going to be complementary to them. So it's going to be going alongside. They can task it to go off and look at anything in particular that they think is interesting, but at the same time it can also hang back and collect data along with the other vessels, which is going to be an interesting change for us because we spent quite a lot of time and effort getting it okay to go across the Atlantic all on its own. Now it's going to be spending a lot of time in relatively close proximity with other ships, which is a sort of a more interesting challenge, especially over longer periods of time. So I've blasted through that. 5 minutes, I think I'm on there. So if you are interested at all, I more than recommend going to mas400.com. I didn't mention, I'm very sorry, Primare, who are the non-profit who own and operate the Mayflower, Marine AI, who built the whole AI Captain package as a whole, and MSubs, who built the Mayflower itself. They were the real stars of the show, and we sort of just came in to help them along the way. So that's really good. I can't say that those Twitter accounts are still working anymore. I think there's been some stuff going on with Twitter recently, so I'm not quite sure if they're working. But mas400.com is the place to go if you're interested in what's happening with the Mayflower right now. But I think, any questions?
Thanks very much. Any questions from the room?
Do you have any plans or aspirations to scale up to larger vessels or use the technology you've made to assist our captains today? Well, soon.
That is a fantastic question. I couldn't have planted you, Yeah. So yeah, no, exactly. So obviously with the Mayflower autonomous ship, it was fully autonomous, but the AI Captain technology is being packaged in such a way that it can be used both as a fully autonomous AI captain, but also as a complementary asset for captains on ships. So it's there to help you to try and identify issues before you've spotted them necessarily, or to at least sort of go, here's a vague idea that I think's right, what do you think? And the captain can then make an informed decision around what they want to do based on those recommendations and the courses that it will have plotted. So yeah, it's very much sort of seen as a complementary technology for humans when they want it, and then can be used for fully autonomous cases if needed for that as well. But yeah, thank you.
Christoph Burmeister, Fraunhofer CML. I've seen a couple of presentations about autonomous systems, and congratulations, first of all, to that achievement. In the video, I think it was a video and not a real show, one thing picked a bit my attention, and that was the VHF speech-to-text conversion. Did you really realize that, or is it only the video part in there at the moment?
Yes, so the sort of the flashy graphics we had, they were made for us when we were in the run-up to developing the Mayflower. That's probably one of the things that we wish we could have implemented. But yeah, it's still on our wish list. Interestingly, there's a lot more work now going on to voice recognition and being able to cut away a lot of that noise and things like that. But it is, yeah, that's a little way down the road for us. But this is, it's an evolving project. As we can add these technologies, we will, definitely. But yeah, thanks.
Thank you very much. Considering your experience now running this autonomous vessel across Atlantic, I was following your project for a long time. I also work on IGNITE project, which is again looking at autonomous operation. So considering your experience from driving this vessel across Atlantic, what do you think, like if tomorrow some seafarer has to move to a remote control center and he is given this job to operate, say, a monitor and a fully autonomous vessel or drive a semi-autonomous, like remote control vessel. So considering your experience, what do you think, what additional skills he need to kind of like upskill himself to handle those vessels or to monitor those vessels?
Just to check, was that what skills do you think someone's going to need to be working in this area? Sorry, just clarify.
Yeah, so now understand like to basically monitor this kind of vessel at sea. So some seafaring skills may also be required, or knowledge should be at least be there. So I'm replacing a technical guy, a technological guy, like a software engineer, with a seafarer, like for future remote control, as a remote controller, sitting in a remote control station. So what do you think now? He already has a seafaring skills and knowledge, but considering the technical skills or digital skills, what do you think, what all he need to upskill himself to kind of do the other way around?
Yeah, so interestingly, I'm not sure that you would. So just for an example, with the Mayflower autonomous ship, when it was making its way across the Atlantic, we had people watching it and there to take control if they needed it sort of at any point. And they were captains from local ships that were volunteering to look at it. They weren't software engineers, they weren't technology-based. They had a little bit of training in how the software worked, and then they just went with it, and they were able to, we did simulations and things, and they were able to sit there and control it. So I think in terms of skills required for this kind of area, for sort of making that bridge across, I'd hope that it would be relatively little. The goal with all of this is always to make the technology accessible to people working in this industry, not to force people into having to become experts at the technology. So that's very much the goal. Does that answer the question? Yeah.
All right, cool. I think a few people in the room are a little bit reassured now. So thank you very much, James. A big round of applause for the presentation.
Thank you.